Question 3. A car is travelling along a straight horizontal road. When the brakes are applied until the car stops at time t seconds after passing A, the point when the brakes are first applied, velocity of the car is given by this. Okay, so this is the velocity of the car, okay, in terms of t after passing A. Okay, and of course the brakes are applied then. Okay. Find an expression for the acceleration of the car at time t seconds. So to get the acceleration, right, you start off with v. Okay, so then the acceleration then will be the derivative of the velocity. So you get minus 18 goes, you get minus 4t. So that's the expression there for acceleration as we saw earlier. So we can write that then as a equals dv dt. Part B. Calculate the time taken for the car to stop. Okay, so of course, if we think about it, when the car actually stops, okay, we can consider that situation. We know something when the car stops, the velocity, of course, will come to 0. All right, that'll enable us then to work out what value of time we've got when velocity is 0. So we'll have 18 minus 2t squared equals 0. We'll solve this. So t squared will equal 9, and that means then we get t, we square root it, we'll end up having t equals 3. We'll take the positive solutions there. Okay, so that's when it stops. Part C then, find an expression for the displacement of the car from point A at time t seconds. So, C, to get an expression for the displacement, you're going to have to go back to V. Rewrite this as the derivative of the displacement, so ds dt. Now separate the variables, so you get ds on one side, 18 minus 2t squared dt on the other. So integrate this, you get s equals 18t. Integrate that, that will become 2t cubed over 3 plus c. Okay. Now, when it says here find an expression for the displacement, and we have found it, but it does say, you know, at time t seconds, right? They want an expression, they want a complete expression. So they, you know, they wouldn't be happy if you just leave it like that with a constant there, right? If they want an expression, that's what they're asking for, aren't they? They're asking for an expression at time t seconds. What about this c here? So we need to work it out. We need to look for boundary conditions. Are there any boundary conditions? And to be honest, I can't see any conditions there. It's not so obvious, right? But if you look carefully, it says at time t seconds after passing A, the velocity is given by this. Okay, so this is based on this car. Okay, the starting point as such for this formula is when it goes through A. So we can think of A as the origin, isn't it? And then this kicks into effect, so to speak, because the brakes are applied. This gets into effect when it goes through A. Right, only when it goes through A, and the time, of course, is when time starts ticking when it goes through A. So when it says here, then find an expression of the car from the point A. Well, of course, at A, t is equal to 0. Yeah. So we can think of the point A. So we can say at A, t is equal to 0. Okay. This is the beginning of that formula, but also s is equal to 0, isn't it? Because that's where the displacement starts. So we'll have 0 for s. T will be 0, so basically c is 0. Okay, so we have s equals 18t minus 2t cubed plus 3. Okay, and then part D, nice and simple. Calculate the distance from A travelled by the car before it stops. Well, when it stops, of course, we know t is equal to 3, so we can just chuck that in, can't we? So t is equal to 3. We just put it in there. When t equals 3. S will equal 18 times 3 minus 2, 3 cubed over 3. So we use our calculator on this. And we get 36 meters.